All right, friends, we're going to do a little bit of a project. I'm here with Caden Wood. Wood or Woods?
Wood.
Caden Wood. Okay, and so we're going to work together. Not sure it got the right screen. There we go. Okay, so it is screen 4. All right, what we want to work on today is the discrete structure exam. And this is one of my favorite operations. All right, so it says compare the number of operations and the time needed to compute Fibonacci numbers recursively versus the those needed to complete them iteratively. All right, so here's all right. So Caden, have you seen the Fibonacci sequence before? Do you remember it from any of the other classes we've had?
I don't really remember it, but I know I've seen it before in Computer Science 1.
Yeah. I didn't realize this. Fibonacci sequences in Indian mathematics, in Sanskrit, Paramahansa. There was an interest in enumerating all patterns of long syllables, 2-unit duration, just opposed with short syllables and 1-unit duration. There's also lots of other fun stuff. Anyway, this is in modern parlance how we kind of visualize it. And so you start out with one pair of baby bunnies, but they grow up, right? And once they're adults, then that pair can make more bunnies. And so it's a early primitive population model. A lot of fun things that go with it. But let's get started with the programming. So I'm going to start up. Oh, I think I started the wrong one. No, I think I might have got the right one. While we're doing that, this time we're going to do this in Python. So we'll do it with a for loop. Yeah, there we go. So we'll work through that with the for loop, but there's also code out there. I get this. Recursive and not Java, but we'll do Python. Okay. So here is a recursive Fibonacci. And so we can work through this. All right, let me fire up a Spider. Do you use Spider?
Or what do you use? A little. I mainly use Jupyter Notebook, but I've been trying to learn Spider.
Okay, we'll let's see if we can get Spider to launch. All right, so let me get this saved in the right spot. File, save as. And C users, Everett J, and Git. And what we're going to call this is oh, don't get old. Don't get old and let go of your memory. All right. So we're going to call this Fibonacci.py. All right. So here's what I would like to do. I'll get you set up. None of this matters. I'll delete that. First question. Does it run it runs. Okay, so Caden, here's what I would like to do for the training video. Over here on the side is other stuff. They won't actually be able to see this, but they can see this screen. So what I want you to do is I want you to come in here and do the recursive work first, and then do sync. I've got well, nope. Yeah. So there's our problem statement. And our recursive work. All right. Do you have a good understanding of how the Fibonacci sequence is calculated? I would say so. All right. So let's go back to this. All right. This is the definition of the Fibonacci sequence as we know it today. So we say f of 0 equals 0, f of 1 equals 1. But what does that really mean? That means we're putting a pair of baby bunnies on an island the first month. So it's 0 pair of adult bunnies. But because they're baby bunnies, the next month they're mature adult bunnies. So f of 0 by definition is 0, f of 1 by definition is 1. And this is how we define this relationship. Now, the next step we can define as, all right, how many months are we going to have in month 2? Well, that's going to be equal to the number of bunnies that we had in the last 2 months. The idea is all right, so let's do f of 2. F of 2 equals f of 1 plus f of 0. What that means is next month, we're going to have as many adults as we had last month. So that's where the f of n minus 1 comes from. But we're also going to have as many adults as we had babies 2 months ago. So that's the f of n minus 2. And how that works is f of n minus 2, that's when we had the babies. F of n minus 1 is when they grow up. And so that's why they'll be adults. F of 2, the current f. All right. So essentially, it's just, all right, how many do I have this month? What did I have for the last 2? Now, what's your understanding of a for loop versus recursion?
For loop just does one.
Like a block of code and it just goes over and over. When people say recursion, what does that mean to you?
It's like a bunch of different stuff that keeps happening over and over.
Yeah, I like that explanation. So for a lot of people, when they say, here's a recursive code, what that means is the code keeps calling itself with a smaller piece of the problem and keeps calling itself with a smaller piece of the problem. All right. So one of the things that, you know what? One of the things that works kind of well is having a counter that is built in a different class. So I'm going to do class, and I'm going to call it data tracker. To stick with the notation, capital D. So I'll show everybody in TV land. This is, I'm using the python.org documents as an example. And let's see. There we go. I remember the example, it works really well for me, had the word data in it. See if I missed it. There we go. All right. So I'm just going to copy all of this code and I'm going to paste it in here as an example. Just go down to the bottom and paste it. Okay, so we have to add. Why is it not happy? Oh, need a full colon. There we go. So we'll have a data tracker, and I'm going to say, well, let's grab our code, and then we'll start to look at it. So we'll do the recursive one first, and this is the code that I'm going to borrow. It's from the programs, and it's a display source code to display the Fibonacci sequence. And so we're going to define a function, and then we'll set in terms, and then we'll have our code that runs. Okay, so I'll just grab all of this code. We'll paste it in here, and let's run it because we've done quite a few things right. And so so what we need to do in order to make this work is we need to we're going to break this problem up just a little bit. So I'm going to come down here, and I've got this data tracker, right? So I'm going to do also self dot function counter equals 0. That's going to be a variable, and that's going to how about that for a more descriptive variable? So I'm going to come down here, and I'm going to say recursive data equals new. No, that's old school. Data tracker. All right, let's run it, make sure I haven't bricked anything yet. And we are seeing the Fibonacci sequence as well. That's cool. All right. So now we've got in terms. I hate that variable name. So let's do this. Control F. Do you have the find and replace? All right. Let's see if it's no. Tools. There we go. Replace text. All right. So in terms, and I'm going to say number of terms because my brain works like that. Okay. So that was just Control R to find it and replace it. So what we're going to do, we've got recursive data here, and we're going to come down. So this will create an object, and the object is outside of the function call. It says number of terms equals 10. If the number of terms is less than or equal to 0, then it's just going to print off a statement. But this isn't part of the algorithm. This is just kind of checking before we run the algorithm. And so then it does a print statement. We don't need to keep track of that. For I in print range number of terms, it says print recursive Fibo. I'm going to disagree with how this code is set up. I don't want to do it as a for loop. I don't need to print the individual terms. I'm going to change this format. I'm going to say formatted print Fibonacci number for terms. I don't like the wording of that, but I'm sure I could take more time and get it to work better. All right, get these lined up. And we'll put in number of terms. Okay, let's run this and see what this looks like. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I feel like the code is doing one more than it's supposed to. And so I'm gonna make just an adjustment, and I'll just do this the kind of the simple way. Okay, yep, now it's getting us 34. Okay, so this is our first number. I'm going to come in, I'm going to try to do something silly. All right, I'm going to try to pass the function two things. I'm going to try to pass it this and recursive data. And so when we come up to our function call, we pass it in and recursive data. Let's see if I can get away with that without it blowing up. It says, you're missing a term. So that means what we need to do here, it says we're missing a term, line 30. That's hard to see that. There we go, line 22. So we come to line 22 and we see, yep, we are missing a term. So I'll drop that in there. Okay, now let's try to call it. It says 34. All right. That's cool. So now we've got this object that we're passing in. Now we can come in and we can say recursive data dot. My brain is complete mush today. Increment. That's how you spell increment. C-R-E-M-E-N-T. Okay. My indentation doesn't work, so I'm going to indent these so they all line up. That makes me happier. Okay. But the problem is this doesn't exist yet. So we have to create it. So I'm going to come up here and I'm going to say def. And I've got to go. You have to pass it self and then whatever variable that you're trying to work with if you need to do another variable. Well, we don't, so we can just call it self. And so then I'll say self dot number of function call equals, I think I can get it, plus equals 1. It's always stupid to try to do new lines of code with something where you're not sure what you're doing. So okay, yep. So I can get away with, should be able to get away with plus equals 1. All right. So now we do that. We're just going to find out how many times that gets called. So let's run it and see if anything's blown up. Nope, it's still working. Okay. And now, so we'll come down here and we'll come back and we'll say dot print number of function calls. Okay. And this again doesn't exist, so we have to create it. And so we come up here. Say copy that. Paste it. All right. Why are you not happy? Because I forgot. You have to pass in self. Okay. Let's slow down on that. I have no idea if 109 times seems reasonable or not. So we're going to work through this a slightly different way. All right. Let's do 0 terms. 0. F5. All right. 0 terms, we call the function 0 times. So I'm going to okay, so let's call this Fibo to, oh, make sure, yep, right account. Fibo all right, so Fibo num. All right, so 0, we had 0 calls. 1, let's go. Now change this to 1. We called the function 1 time. Cool. So I'm lazy. I'm going to try to use this pattern. Yeah, that'll work. Okay. We'll come back and we'll change this to 2. And it's still 1 time. I can believe that. Change it to 3. Called the function 3 times. This seems reasonable. Let's talk about that right quick. So f of 1, it's going to come in and it's going to say f of, we'll pass in, this becomes number of terms is equal to 0. It says, please pass a positive number. And then if we pass in a 1, this becomes 1 minus 0, which will be 0. So 0 gets passed in as n. If n is less than or equal to, so it would do one function call, so it would do this once. But 0 is less than or equal to 1, so it would return n, and that's the end of it. So one function call. For 2, so when we had this set to 2, it would say pass in 2 minus 1 would become 1. 1 is equal to 1, so it would return 1. Cool. Now we're going to pass in 3. This is when things start to get interesting. So 3 minus 1 is 2. So we pass in 2 up here. Now, n is not, 2 is not less than or equal to 1. So it goes to the else statement. And now it does 2 function calls. 1, 2. We know that when we do this first function call, it's going to return n. When we do the second function call, it's also going to return n. Therefore, to do 3, it's going to take the initial function call plus this one, so a total of 3. So that makes sense, and I can agree with that. So now we go to 4, and we run it, and it says now we've called it 5 times. All right, well, let's record our data. So we set this to 4. 4 minus 1 is 3. So n is now 3 up here. So we call the function once. And then 3 is more than 1. So we call it a second time. N minus 1 is going to be 2. And n minus 2 is going to be 1. So, and then when we pass in n minus 1, that's going to be 2. So pass in that here. It's greater than this. So we'll call it a 4th time and a 5th time. So I think our little tracking system is working pretty well. All right. So reading the question again, it says compare the number of operations and the time needed to compute the Fibonacci sequence. All right. So every function call essentially has one if statement. So for the recursive, we can make more data gathering stuff. So we can do if count. And so every time it does one of these, we can come in here and we can do self dot if count equals 0. No, I'm just going to do if count. Sorry. I'll come down here. Plus equals 1. Why? Oh, because I forgot to import self. Okay. And then we can also keep track of here on this if statement, we can do recursive data dot add count. Because we're doing an addition. And so count, and then I can copy this. Let's try to be as lazy as possible. Okay, so that's going to do our add counter, our if counter, and then we've got two subtractions here. So the way I'm going to do this, oh, don't forget to import self. Also helps if you have the cursor in the right spot. There we go. But I screwed up just a little bit, right? Because it's not just one subtraction, it's actually two subtractions. So we've got to do this twice. Okay. Well, there's one other piece of data that we're supposed to keep. Yeah, we got 10 minutes. We're going to finish this up. All right, so there's one, if we go back to the problem statement, it's the number of operations and the time needed to compute the Fibonacci numbers recursively. Okay, so what we need to do is we need to also have some way to do timing. And so Python time execution time. There we go. Real time, though, including time used by other programs. So it seems to take more time when your computer is doing other stuff. The same thing, but use time.clock instead. You'll get slightly better accuracy. Okay, so time.clock. So yeah, this will work. Import time, and we'll do time.clock. All right. Oops, need to get the spider. There we go. All right. So we're going to come down here and well, let's go. This is horrible, unorganized programming. It's ugly. All right. So I'm going to change this to recursive data. So now I've got, why is it not happy? Oh, probably because I pulled the trigger too soon. I'm going to come down. There we go. All right, now I need to grab start time. I think it'll handle doing what it needs to do. So I've got that. Before we go too far, to run it, make sure nothing blew up. It says time has no attribute clock. See, that's a problem. Import time, time.time. But use time.clock. Okay. All right, let's just use time.time instead of time.clock, because I'm relatively okay with. Cool, and that works. Okay, now I can do this. Come down here. Okay. It didn't have a stop time holder, but it needed one. So let's grab this stop time. Okay, so now we can do, I'm going to change this function. I'm going to change it to print from data. Okay. Oh, you know what? That's what there, and it needs to become this. And so replace with yes, print function data. All right, now we can do this kind of stuff. All right, we called the function. We added, so we can do self.add count. And oh, we can also do and then because I'm lazy. Cool. All right, time and time seconds. No, how about self start time, self stop time. Sweet. Okay, run it. Cool. All right. So, Caden, if you ever wonder why in computer science 2 I get excited about using objects, it's because they do stupid things really well and complicated things. Now, let me ask you a different question. If we were to do the same thing with the for loop example, how long do you think it would take?
Probably longer.
Not as long as you might think. Okay.
Because we're using recursive right now, right?
Right. But I mean, as far as to program it goes.
Oh, yeah, to program it wouldn't take as long.
We already did a lot of the heavy lifting. So let me see if I can go. Let's see. Yeah, you know what? Somewhere I lost my stuff. So let's just do this. Python Fibonacci for loop. That'll work great. Let's use programs again. Okay. So it's with a while loop. I'm okay with this. So we'll do this first. Come in here. No, we definitely don't need this anymore. Paste in the URL. Copy the code. All right, so we're not going to do it this way. Instead of in terms. All right, so you double click that, you do Control R. And then you should be able to and that's all of them. Okay. So now let's run this. We haven't gotten too crazy yet. So Fibonacci for 4 terms is going to be 2. So 0, 1, 1, 2. I agree with that. And Fibonacci sequence down here, it's printing 0, 1, 1, 2. Okay, so now we can come down here and we can say, instead of recursive data, we'll say iterative data. And so again, we're not going to do count that. So that won't work. But right here, we had an if statement. So I'll do iterative data dot increment if count, because a while loop actually is an if statement at the start. So that's cool. We do that. And then we say iterative data dot increment add count, because we're doing addition here. And then, hey, we've got something new that we didn't have before. So data dot increment assignment count. And so this is something we overlooked in the previous work. No, because there are no real assignments. So I need to come up here. And I'm gonna, this is ugly, and I know it.
Spacing looks nice.
Well,
You looked at email yet, but after class, I'm gonna go over and clean that grade change. And I go over and I did the big one, yeah, she didn't make it up. So keep it up. I even gave her, originally, the thing I sent out, said the original plan was to have it done before spring break. Beginning of spring break, I extended another week, and save the spring break.
oh, you have to import self.
You know, those don't make much difference. Yeah.
Okay,
She did them the day.
and then
Last day.
we did So that's what we needed to do to increment an assignment count. So we'll do that here, here, and here. Okay. And then we need to do, we're done with all of this. There we go. We'll do increment iterative. That's what it. Iterative data dot function data. I messed up on one thing though. We need to come in here. And right here, iterative data dot start time. Equals okay. Now let's see what that looks like. That annoys me. Run it. Fibonacci sequence. Oh, you know what? Okay. Zero assignment operations, and both of them are 5 seconds. Well, that's not very interesting. So let's change this to 10. Still not very interesting. 20. Still not very interesting, but it's starting to get there. 40. I don't know if you're noticing this or not, but I'm just doubling it every time. Okay, now we're starting to see something interesting there. 80. And so now we're starting to see a little bit of a difference. Oh. Oh no, it's still running on 40 terms. It's busy right now.
Oh, from the last one?
Yeah. Hey man, that's interesting. All right, so that's how you can go out and you can start to get stuff. All right, so I'm gonna go ahead and bop over here. All right. Where did I put this? Oh no. That was a horrible plan. So it needs to be inside Git, but no. All right, somewhere I have messed up because I can't get this out to the world. So I'm gonna go here to Canvas. Yeah, Canvas somewhere. And I'll just post this as a reply. Oh.
I locked your door.
Ah, thanks, Kim. Problem is, I just have too much fun doing this stuff.
Enjoy your job.
I enjoy these kind of problems. I'm hunting right now for the Canvas page because I might have, oh, there it is. So I'll come in here and I'll just post a reply. And there you go. So that's all of my code. All right. That is how to work that last test. And I think I need to slip some of those assignments a little bit. So anyway, I'll take care of adjusting that later. Thanks, everyone. Bye.